Yeah, in this problem, uh, we are going to discuss about the source transformation. Source transformation in the sense how to transform voltage source to current source and also how to transform current source to voltage source in what application, in what place we need to transfer. That is what we're going to discuss about. The problem statement is calculate Vx in the circuit using the method of source transformation. Okay. We can calculate Vx using other techniques, but here, since it is mentioned as method of source transformation, we are going to see that, and it is an easy method too. We need to know for solving this problem, and seeing the problem itself, we can know we have to calculate. We need to know how to calculate the source current from through Ohm's law, and also we need to know how to calculate the parallel impedance, like parallel resistance that we calculate in DC circuits, how to calculate parallel impedance and also series impedance, that formulas, and how to convert, what is the procedure and formula to convert current source to voltage source and voltage source to current source, that we need to know. That are the three steps we need to know. And at last we will have calculation, final calculation, which is voltage division rule and current division rule to find Vx. Okay. On seeing this circuit, it may look simple, but we have to know all these four formulas to find the answer. What is Vx? Okay. Now, uh, in this step, we have two mesh. We also can calculate Vx using mesh analysis, if you want. Okay. First, what we have done is we have to transform this voltage source to current source and obtain Is. Okay. Anything, any current, any voltage source which is in series with a resistance or impedance can be made to current source in parallel with the same impedance. That is the procedure. I repeat it. Any voltage source in series with an impedance can be converted to current source in parallel with the same impedance. So here the series impedance is 5 ohm. So what we need to do is we have to divide this. For finding current, the Ohm's law is the simple formula. So current, so voltage divided by the impedance will be your current. So I is equal to the total voltage 20 angle minus 90 divided by the series resistance is 4 minus 90 degree. Minus 90 degree can be taken as minus j, so it is minus j 4 amps. Is is equal to minus j 4 amps. Now the circuit changes into a different form. I'll show you the circuit which is given below. See, the current source come here and the series impedance come to the parallel form. All other circuit are same. Okay, this is the first transformed circuit. Then what we need to do is we have to find Vx. So for finding Vx, we don't want this number of parallel circuits, so we have to combine these two uh, impedances. So for combining these two impedances, we have one impedance 5 ohm, another impedance which is 3 plus j 4 ohm. So for combining these two, we can use parallel combination of impedance. Parallel combination of impedance is nothing but uh, this one into this one divided by this one plus this one. That is the parallel combination formula. That is Z1 into Z2 divided by Z1 plus Z2 is the formula. Okay. So for combining these two, we are assuming a notation called ZL. It can be taken as Z1 also. So Z1 is equal to 5 into 3 plus J4 divided by 5 plus 3 plus J4, which is 8 plus J4. So it becomes 2.5 plus J 1.25. So the circuit becomes one current source, a parallel impedance which is 2.5 plus J 1.25 ohm, and other circuits are same. We have done this because if there are many parallel impedances, then we cannot calculate Vx easily. So we are combining the parallel impedance values. Okay. The next step is converting the current source to the back to the voltage source. Okay. Now the circuit is like this. We have a current source. We have parallel impedance here, which is 2.5 plus J 2.5 ohm, and other things are same. What we need to do is A current source in parallel with the impedance can be converted to voltage source in series with the same impedance. So we have to multiply the current with the impedance, so that we will get the voltage source, and this parallel impedance can be made to series. That's it. See the circuit here. Now the current source is converted to voltage source, and this 2.5 plus J 1.25, which is in parallel, is made to series here. How this pi minus J10 came? It's nothing but the multiplication of this one, this Is, along with the ZL. Okay, so Vs is equal to Is into Z1, which is minus J4 into 2.5 plus J 1.25, which is equal to 5 minus J10 volt. Now we got Vs, we have Vx here, and we need to calculate voltage across this 10 ohm resistor. All other things are should be made to same impedance. Then only we can apply voltage division rule. These four things has to be combined. This resistance, inductance, another resistance, and capacitance should be combined together, and this 10 ohm should be made separately. Okay, it is already separate only, so we have to combine this one. So if we combine all these things, we will get 4 plus 2 is equal to 6 ohm, and this one j minus 13, j 1.25, it will become j 11.75 ohm. Okay, so we have to apply voltage division rule. We know what is voltage division rule. This voltage is going to divide into one part for all these things and another part for 10 ohm. Okay, so what is the rule is, when we want to calculate the voltage across this one, that should be multiplied with this one divided by the whole total impedance. That's all. Okay, so here we have to find voltage across 10 ohm. So the 10 ohm into 5 minus j10 divided by the total impedance. That's all. So the answer is 5.519 angle minus 28 degree. This is what the answer is. Here we have applied only three steps. One is finding the current from voltage, combination of impedance, and then back finding the voltage from the current, and then we have applied voltage division rule. That's it. Thank you.